Today we're going to be discussing the next logical connector, the conditional. Let's get started. To begin with, for a conditional statement, it is the statement if P then Q, and it's always symbolized as an arrow. The other thing to note is your book will call this the implication. So an implication in your book is the same thing as our conditional statement. If P then Q is our general conditional statement, but there are several other statements that mean the same thing. So all of these statements are going to be equivalent to the if P then Q statement and are going to be translated with a P arrow Q. Most of them are going to make sense because P is on the left and Q is on the right. So for example, P implies Q is going to be a P arrow Q symbolically. Same thing for P only if Q. So these two words mean the same thing as if P then Q. However, if we see, for example, 3, we have Q if P, the Q is first and the P is second, but it's still going to be translated as P arrow Q. So all these statements, even though they're worded differently and Q and P could be on different sides, are all going to be translated as P arrow Q. Let's look at some examples. So for our first example, we have the statement, I will understand the homework whenever I watch the videos. The first thing we want to be able to do is identify what our statements are. So we have two statements. I will understand the homework, and I will watch the video. The next thing we want to identify is what word is connecting those two statements. In this case, we have whenever. If you go back to the previous slide, for our whenever statement, Q is on the left, and P is on the right. So if I want to translate the statement into symbols, we want to look at our two statements again. I will watch the videos, that's positive, so positive P. And then I will understand the homework, so we have a positive Q. For our next example, again we want to identify our two different statements for the statement. Not watching the videos is a sufficient condition for not understanding the homework. So we have two ideas here, not watching the videos and not understanding the homework. The connecting words are sufficient condition, or just the word sufficient. So again, we want to identify from that list, for the sufficient, is it P is sufficient for Q, or is it Q is sufficient for P? In this case, it always follows as P is sufficient for Q. So I know that my left side of my statement is going to be P, the right side of my statement is going to be Q. When I go to translate this, I have P arrow Q, however I have not watching the video, so I need a negation, and I also have not understanding the homework, so I need another negation. So this whole statement could be translated as negation of P, arrow negation of Q. For our truth table, we have one instance where a conditional or an implication is going to be a false statement, and that would be for our second row here. If we have true, arrow, false, then our whole statement would be false. So something that's true cannot imply something that's false. However, every other condition is going to work. So if we're looking for a pattern here or a shortcut, we could say that this statement is always true unless it is true then false. Let's go ahead and apply this to some truth tables. Alright, so our truth tables always start the same way. True, true, false, false, and then true, false, true, false. For our third column there, we're going to negate P, so we're going to change all of that to be false, false, true, and true. Then as we move forward for our conjunction, the pattern there is that it's always true as long as both sides are true. So we're going to be looking at P and Q, and the only time that both sides are true is for that first row. So true, everything else is false. Now we're going to be looking at the conditional. And for the conditional, we need the negation of P and the conjunction of P and Q. So we have our third and our fourth column. Again, the pattern for the arrow is it's always true unless it's true then false. So for our first row we have false and true. That's true. False and false is also true. And then true then false for our last two examples, this is where our conditional is going to be false. The last we want to look at is for our final column, is this a tautology or a contradiction. And in this case, since we have a mixture of trues and false, it's neither. Alright, for our next statement, we are adding in a third variable. So we have three simple propositions. We have P, Q, and R. To determine the appropriate amount of rows, each statement has two options, true and false. And since we have three different propositions, we have 2 to the third amount of rows, giving us 8 rows. Our pattern is going to remain the same. We're just going to have to readjust it for 8 rows. So initially we had 2 trues and 2 falses for P. That pattern is going to stay the same, where we have half true and half false. So we have half true for P and then half false. Then for Q, it alternated as true, false, true, false. And we're going to alternate as well, but we're going to alternate by 2s. So true, true, false, false. True, true, false, false. And then finally for R, it's going to alternate every other one. So true, false, true, false, true, false, true, and false. Our 3 columns are always going to start this way for a P, Q, and R truth table. Our next step then is to look at our inclusive disjunction. So we're going to be comparing P or Q using the V. And again, the pattern for that is it's true as long as you have at least one column being true. So true, 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 true. And then if you look at our last 2 columns, or last 2 rows I should say, we have both falses, so now it's going to be false. For the negation of P, we're just going to switch out our P column to the opposite. So instead of half trues and half falses, we have half false and then half true. Alright, now we're going to be taking the conjunction of R and not P. So we have R and not P. And again, the conjunction is going to be true as long as both statements are true. So we have true and false, that's false. True or false and false is false. True and false is false. False and false is false. So we only really have 2 instances where they're both going to be true. So that was this row and this row. So false, false, false. Again, we have both trues for this row, false, both trues here, and then another false. Alright, and now time for our final statement. So for our conditional, we're going to be comparing the inclusive disjunction with our conjunction. And again, the pattern for our implication here, conditional, is it's always true unless it's true then false. So true then false, that's false. True then false, that's false. True then false is false. True then false is false. True then true is true. True then false is false. And then false and false, those are both going to be true. Again, we look at our last column. We want to identify, is this a tautology or a contradiction? In this case, it is neither because you have a mixture of trues and falses. Alright, that concludes our video. We discussed the truth table for a conditional statement. We also discussed translating. You're going to be using both of these for your in-class assignment on Monday. See you guys in class.